right, we're going to look at page 1 of our tangent practice. And we're going to start with looking at number 1, how to do this. Now it says determine if AB is a tangent to the circle. And if we remember from our circle book notes, on page 3, we talked about tangents and radii are 90 degrees or perpendicular to each other. So if this is 90 degrees and we don't know, then the Pythagorean theorem should work. Now if we remember, right here, A to the center has to be 12 because 12 is a radius. So they must be equal to each other. So this must also be 12. So then we're going to add up these two sides, giving us 20. And then we're going to say 16 squared plus 12 squared equals 20 squared and see if it works. So 16 squared plus 12 squared, and remember square them first and then add them together, gives us 400. And 20 squared gives us 400. So yes, it is a tangent. Okay, let's move down to number 6. Okay, number 6, it says find the segment length indicated, assuming that the lines that appear to be tangent are actually tangent. So if this appears to be a tangent line, it must be. So that must be a right triangle. Now, we know that this is a radius, and so is this. So it has to be 1.5. Okay, so now, do you guys see the right triangle that I have here? I'm going to use Pythagorean theorem again. I'm going to say this side is 1.5 squared plus, we don't know, this is a question mark, squared, equals across from the 90 degrees is my hypotenuse. So I need to add these two together to get it. Gives me 2.5 squared. Okay, 1.5 squared is 2.25 plus my question mark, or I could have made it x squared, equals 6.25. I'm going to subtract 2.25 from each side, and I get question mark squared equals 4. Now I'm going to take the square root of each side, and I get question mark equals 2. And I'm done with that one. So it was just figuring out what the radius is, which ones were in common, and then figuring out which was the hypotenuse to put into Pythagorean theorem. Okay, let's look in the back of this worksheet. So we are going to look at number 9. Okay, remember this is all about our common radii. So if we look again on page 3, if we have a common point for two tangents, they have to be equal. So if this is 10.5 right here, this also has to be 10.5. If this is 11.2, this has to be 11.2. Okay, but how do I figure out what this part is up here? I'm going to go 23.2 minus 11.2, and I get 12. So I'm going to ignore this now, and I'm going to say that both of these are 12. Okay, and it wants to know the perimeter. So that's the one thing I forgot to do before I did this, was read out loud what the directions were. Find the perimeter of each polygon. Assume that the lines that appear to be tangent are actually tangent. So I've got all of those, so now I'm going to add them all together. 10.5 plus 10.5. I'm adding up the outside as if I'm walking around. Plus 12 plus 12 plus 11.2 plus 11.2 gives me a total of 67.4. So I've walked all the way around the outside. And I've figured those all out by common tangents. Okay, number 10 is very similar, except it is a quadrilateral. And if we remember from page 4, opposite sides of the quadrilateral, if we add them together, are equal to the other opposite sides. So we're going to start right here and see what we've got. I've got this whole side is 25. This whole side is 21. Just this little bit right here is 13. This is 4.6. Well, I know that if these are both if one is 4.6, the other one is 4.6. Okay, but I have no idea what this part is here. All right, well, I can figure it out by using that formula. If I add these two sides together, they need to equal these two sides. So I'm going to say 13 plus 4.6 plus 21.8 equals 25 plus 4.6 plus, I'm going to call this little part right here, x. And I'm going to add them all together and subtract, and I get x equals 9.8. Now, that is not what the question asked me. The question asked me what is the perimeter. So now I have to add everything together. 13 plus 4.6 plus 9.8 plus 21.8 plus 25 equals 78.8. All right, now we are going to go on to 13 at the bottom, but again, I found this out by saying opposite sides, when we add them together, equal these other opposite sides, found the missing part, and then just added up the outsides for perimeter. Number 13, I want to find out what this angle is. Okay, well, first, I know that a tangents appear to be tangents, so I know that has to be 90 degrees. But I also can see this other triangle right here. Well, this other triangle has two radii in it, which means they have to be equal to each other. Which means this little length right here has to be 63. So now I'm going to take 180 minus 63 minus 63 is going to give me this angle down here, 54. How does this help me? I now have this triangle here where I know two of the angles. So I can take 180 minus 54 minus, this is 90, remember, gives me 36 degrees. So that is that angle right there. Okay, let's look at 15. 15 is a kite. We know both of these are the radii. This meets at 90 degrees right here. So these two sides must be equal. They meet at an outside point. And do we know what the interior angles of a quadrilateral is? Gotta wait way back. It's 360. So 360 minus 117 minus 90 minus 90 ends up being 63 as our answer. Okay, again, the interior angles of a quadrilateral add up to 360. All right, number 16. We want to know what this angle is right here. Anybody can tell me where 90 degrees would go? Do we have a tangent and a radius? Remember, a tangent only touches at one point, so this can't be a tangent. This can't be a tangent. This is a tangent. So this meets at 90 degrees. Okay. Next, anybody can tell me any of these sides are radii, meaning they go from the center to the edge of the circle. Oh, there's one. There's another one. There's another one. All those sides are equal. So let's look at this big triangle first. Well, I have 2 out of the 3 angles, so that should be pretty simple. I go 180 minus 52 minus 90 gives me this angle up here, which has to be 38 degrees. Now, if we look at this smaller triangle right here, 2 sides are equal. It's an isosceles triangle, this triangle, the blue one. So this also has to be 38, right there. So if we go 180 minus 38 minus 38, we get 104 degrees for that little question mark right there. Again, I used what I know about tangents and right angles. I used what I know about the interior angles add up to 180. And I used radii to realize that 2 things were an isosceles triangle. Okay? All right, so we will move on to the next page of tangents.